Good morning, afternoon, or evening. I'm John, and going to go through. I don't know what to title this. I'm going to show you some ideas in Rust. Um, Part of this is sort of doing object-oriented programming without objects, sort of getting away from, not getting away from, but not having to use a full struct and the full sort of logical object definition when trying to do some functionality. So what I want to do is quite often in a program we'll have a set of statements like this. Let me give you some real estate to look at. So let's say I'm doing for I and yeah something like this, and I want to determine whether or not I've seen this value before. Let's actually let's do this like this, where we're gonna map this into V. We're gonna take a mod 5 of this. So just so you can see what it does when I run this, we're going to print 0, 1 through 4, 0, 1 through 4. And quite often, if we're doing like a network, some sort of network device, we want to sort of log the first time that we've seen that, because the system comes up, other components come up in the system, and at some point we get kind of like we get data, and we want to, as a developer, sort of get a message printed to say, yes, I have seen that other device for the very first time. So like in this case, I only want to print hello world if I have seen this value once before, and do it from a debug point of view. So what I really want to say is seen equal and I want to say log if seen, and I'm gonna I've seen the value like that. So I'm kind of writing in my little API that I want to do, and here we're going to call seen before on I. Now this isn't defined yet, so we're getting compiler errors. So there's a couple of ideas here. One is like just the concept of doing this sort of logging. The other is doing this without creating objects. And the third one is sort of like, if I want to, write this log if seen, do I need to sort of pull in and accumulate a library of common functionality, or is this something that is so easy to do that I can do it on the spur of the moment? Doesn't really matter here, and I'm touching some other things in this, so I don't want to get this too polluted. But I'm going to start with lib.rs, and I'm going to say function log if seen, and we're going to take in the log message, which is going to be a string reference, and I'm going to return an impl function, and the function needs to take in a value. Yeah, we're just going to do a value, and it's going to be of type T. So we need this to be generic, like that. And that's really it for that definition. That's what it looks like. We haven't returned anything, so let's just value. Let's make this compile, and we got to make that pub, and well, we'll let that error out or warn out. It says doesn't see it in the scope because we haven't pulled it in. Let's import that, and so now we're running. We're doing what we want, and we're always going to see this hello world because I want to see that. But really, what I expect to see ultimately is that these first four are going to say, I've seen the value of this, and then otherwise. Now, this returning an impl function, this sort of gets into the object-oriented without objects, where the traditional way of doing object-oriented programming is that we define a struct, or in C++, there'd be a class, a logger, like that. And you would define your methods, and you'd contain the values, or kind of what you're carrying along, your member values, inside the class. And quite often, and this gets into, I would say, a Rust way of doing development, is that there are many things that just perform one operation. And there's certainly some value in creating a struct, so you have this idea of that here's the container of the object, but to return an impl func with something that is just going to be called like this, because if this were object, then this would just say like .log. So, why do we need .log? And we're not doing this because we don't want to do .log, but more that the more code, the more information that's in there, the more challenging that can be to sort of maintain and understand. Arguably, this is as challenging, if maybe not more, if you're not used to seeing this. So I think once you get into this mindset, then doing things this way is perfectly valid. So let's go ahead and get into the implementation of this. So the way we want to store this, we want to have a let mute scene equal that. Yeah. Let's pull in the namespace. There we go. So we have this value scene, and it's going to be a hash set new of t. It's actually hash set of t new. There we go. So far, so good. Currently it's saying it doesn't need to be mutable because I'm not doing anything with this. So how does this work? Well, we say, yeah. If scene, no, let's not do this. So if scene contains, we have to move this in here. If scene contains that, really if it doesn't, actually we need to do this. Scene, there's like an insert value. We do it this way. If scene insert value, and we're going to use println. That's fine. Println log message value. Good. There we go. So insert says that it exists for this set, but not because these bounds weren't satisfied. So it says that for hash set to be able to store this internally, we need to have EQ and partial EQ to be defined. Cool. So let's just put in those trait bounds where t, does it need to be hashed? There we go. It probably says it needs to be hash, yeah. Plus hash. Cool. And then value here, we have to put another trait bound saying that this value must be printable as a debug. So plus standard format debug. So we're putting trait bounds on our function here. This will complain because of lifetimes, because it captures a lifetime of log message. So to fix that, we can just allow the compiler to elige, you know what I mean. Parameter type may not live long enough. So all of the, so we have to also make this be plus static. Borrow scene, cannot borrow scene. It's mutable. It's a captured variable. So this really has to be an fn mute. And we got one more, borrow of moved value. And we need this to be copyable. Plus copy. Cool. So a lot of we've levied a lot of requirements onto this. I actually want to make this to be clone, and we're going to clone this here. Which seems like this is sort of, heavyweight. And I mean, it will be if you're passing in types that are really, really big and expensive. But like this is going to work. And for things like integers, these are the clone is a no-op. A clone will just defer to copy. So let's just see if we run this. Sorry, cannot borrow this as mutable. Seen before, so we do have to make this be mute because that's going to be changing. And now we get, let's expand this up, we get the functionality that we want. The first 4 times we've seen this, we print the value 1 through 4, 0 through 4, and afterwards we've seen it before, so we don't print anymore. So I guess what's the takeaway of this? A lot of stuff I think in this little demo here. One is being able to capture sort of member values inside of a lambda return, this closure that's going to capture this and allow the compiler to sort of store member variables and create a logical container for what this is. The other is looking at generics for this to say, okay, we want to log if we've seen something. The value that we're going to pass in is t, and in order to do that, we need all of these constraints on the type t. It has to be comparable, has to be hashable, has to be able to have a debug print and static lifetimes and cloning. A lot of overhead, you could say. But like if it will protect us. So if we try to say, have we seen this reference before? That's not going to work because, like it says, the I does not live long enough. So I can't store that. Does not mean that you can't store references. You just can't do it in this way because I is does not live long enough, like it says. Just for grins, we're at 12 minutes. I apologize that I think I kind of rambled a little bit. Let's do this in the struct way. Log if seen. So what would I say? Yeah, I would store. Well, we need to have this store a t and a hash set of t. Let's impl or derive. Come on, derive default. And let's impl t log if seen of t and pub fn log mute self log message. Let's store the log message in here. Stir. So now we need to have a lifetime on this because that needs a lifetime. Good. We don't put this message here. So we need to put all of our constraints on this where, there we go. Good. What's it complaining about here? Oh, the lifetime. Can I don't need to define a lifetime here. Log message and seen are never read. Is that true? No, it is here. Oh, because we haven't made this pub. There we go. So this should be our same version we had before. Let mute. Seen before too. Come on. Seen before 2. Log if seen default. Doesn't know what the type of T is, right? I actually I can't use default. I need to have a new here. Pub fn new. Log mess. Yeah, that looks right. It's probably will complain. Lifetime may not live long enough, so I need to tie this to tick A. And now I can't elide this here. And I need to have that there. Good. Okay, so now I can do a new. I've seen instruct. I've seen the value. Good. I'm not using this. Seen before 2. Log I. And this should be noisy when we run this, but now we say instruct, I've seen the value here, and instruct, I've seen this. So functionally, these are now identical. Let's compare those two, because this is not without cost here in just your the implementation. So let's look at here. I don't really care about lines of code, but it certainly comes into play. So, we have this many lines of code from 35 to 15. So that's 20 lines of code. Here we're at 13 to 3, 10 lines of code. Half the size in the function version of it. We had to explicitly declare what it is that we're sort of capturing here in the struct version, which is not bad. It's sort of good to be able to say, here's exactly what it is I have. Does that really matter in most cases? No, because like this is going to be really the same size as this. You just don't have to do it. So you're allowing you're allowing the compiler to infer size and do the work of constructing data values that you're going to capture. There's a little bit of, I'm going to say, additional overhead to say that we need to have, these explicit lifetimes. We couldn't use Elysian. I think that's the right word. To make this happen. We had to define a new and a log as sort of, two separate operations. Again, kind of good to be able to declare exactly what it is that's doing it and where the work is done. But it definitely is I'm coming from an object-oriented mindset. This is how I do it. I was going to conclude saying one is better than the other. For me, this works really well. It makes a lot of sense. You're allowing the compiler to take care of building some sort of version of fnmute that is sized enough and captures all the values. In the struct version, you're being a lot more explicit. Feels better a little bit in the struct version. Again, if maybe you're coming from a high critical software where you need to know everything, and you want everything right in front of you. For me, like I see everything in front of me here, even though it's inferred. So it is a tough call with that. But I certainly love this sort of look to it. Very easy to have everything all encapsulated in one spot. We're not separating it out in structs and implementations. It's all right here because there's only one operation this does, and it just does it really well over and over and over again. So I'm hitting that 20-minute mark. I seem to always do that. I hope that I'm not rambling too much. I'm trying to say things repetitively because these are tough concepts to understand coming from one language methodology to another. So I think it's important to have this information sort of dealed out in different forms from a learning and understanding point of view. So that's my thing here. Um, really really useful little operation to have in play here. Um, really cheap to implement. Really cheap to use, and really a useful tool to have in order to be able to do very simple functionality that gives you a lot of value in the information that it provides to you as a developer. Okay. That's my that's my talk. I'm going to end this here so that I don't continue to ramble. Have a great day.